Hi everyone, I'm Ouano, and for this tutorial, I'm going to teach you all about propositions, its connectives and logics, as well as constructing a truth table. So let's start.
So, what is a proposition? A proposition is a declarative statement, meaning it gives information and can be answered by true or false. Also, a declarative statement doesn't command or ask a question. The truth or falsity of a statement is called truth values and can be denoted as T if the statement is true and F if the statement is false. While in computers, 1 is considered true and 0 for false. So here are some examples of identifying if a statement is a proposition. Rodrigo Duterte is the 16th president of the Philippines. This is a proposition as it is a declarative statement. By checking facts and proving it, the statement's truth value is true since Duterte is the real 16th president of the Philippines. Next example, 5 plus 5 is equal to 9. This is a proposition since it is a declarative statement. We can determine its truth value by checking facts and proving it. 5 plus 5 is not equal to 9. It is equal to 10. So its truth value is false. Last example, where do you live? This is not a proposition since asking questions is not a declarative sentence. Therefore, we cannot determine its truth value since it cannot be answered by true or false. So there are two types of proposition, the simple proposition and compound proposition. The simple proposition contains only one proposition statement. An example of these are the painting is very old and Tim bought a Ferrari. As you can see, both of these are just one independent proposition statement. While compound propositions contain two or more propositions joined by connectives. And these connectives are words such as and, or, if, then, and only if. Examples are the painting is very old and it is very expensive. As you can see, these are two propositions joined by connectives and. Example, if Tim bought a Ferrari, then he is very rich. As you can see, these are two propositions joined by connectives if and then. So the connectives can be turned into symbols. So here are all the list of all the connective symbols. So the first column is the symbols, the second is the purpose of each symbols, and the third column is the translation for each symbol. The propositional statements can also be turned into symbols, which is the commonly used is the P, Q, and R. So here are some examples of simple propositional statements turned into symbols. So the first example is I passed the exam. This can just be denoted as P. And the second example is Mary won the game. This can also just be denoted as P. While here are some examples of compound propositions turned into symbols. First example, if I will study hard, then I'll pass the exams. Since there are two propositions, P will be I will study hard and Q will be I will pass the exams. Next example, Ray likes pizza and Joshua likes fries. The first proposition will be Ray likes pizza, which is P, and the second proposition will be Joshua likes fries, which is Q. Since we already know what is propositional and connective symbols, here are now some examples of propositional symbols with connective symbols. So for our first example, if I will study hard, then I'll pass the exam. Here, I will study hard will be our first proposition, so it will be our P. Then, our second proposition will be I'll pass the exam, so it will be our Q. And as you can see, the connective used in the statement is if then, so we will use the implication symbol. So if we arrange the symbols, this will be the resulting answer. For our next example, the symbols and the proposition P and Q are the given. Now we will try to convert this into a statement. Here we can see that the connectives used are the conjunction and the negation. So if we try to arrange it, P, which is the mark watch movies, then the conjunction and the negation of Q, which is the not play video games all day. So this will be the resulting answer. Now let's move on in constructing a truth table. So what is a truth table? A truth table is a chart that shows the true value of every possible combination of the given compound proposition statements. So the first two columns of a truth table should always be like this, where P should always have T, T, F, F, and the Q should always have T, F, T, F. Connectives have a huge part in creating a truth table. The first one we will discuss is the conjunction, which is true only if both is true. So in this case, this part is the only true and the rest is false, since these are the only times where both propositions is true. So the next is disjunction, where is false only if both proposition is false. And in this case, these are the only false and the rest are true, since these are the only times where both proposition is false. So the next one is the negation, where is always the opposite of the proposition's truth value. So in this case, all of these are the opposite in the proposition P. So the next one is implication, where is false only if P is true and Q is false. So in this case, these are the only times it is false, since these are the only times where P is true and Q is false. So the last one is biconditional, where is true only if P is equal to Q. So in this case, both of these are true, since these are the time where P is equal to Q. So if there's parentheses in your truth table, it should always comes first, just like in any mathematics. So this is an example. What we will do first is write the basic format, which is this. Then we will solve the one in the parentheses, which have the disjunction. After finding the answers, we will now proceed to the next connectives, which is the biconditional. So these values will be true since these are the times where P is equal to the one in the parentheses, which is told in a biconditional.
So that's all guys for this tutorial. I hope you learned a lot in this video and thank you for watching.